So let's talk about the most important feature of ZAP. Of course, it's scanning. We've already seen the quick scan feature of ZAP. So now let's have a look at scanning with ZAP in depth. First, I want to scan Damn Vulnerable Web Application DVWA without a valid user or session. So to start a new session, from the File menu, select New Session. In Firefox, while the port 8080 of the local host is selected as proxy, visit the OWASP BWA website and click Damn Vulnerable Web Application link and go back to the ZAP window. So here, a subfolder for DVWA is created as we expected. Right-click the folder. So in the Attack submenu, select Spider to crawl the application. And there it is, the spidering is finished in almost milliseconds. But as you know, DVWA allows you to only visit the login page if you haven't logged into the application. So ZAP can only crawl the login page and some images and cascading style sheets, and that's about it. So if you start the active scan in this situation, all the attack modules will run on the login page only. So you can only find out the vulnerabilities of the login page. So sure, the attack is completed in under a second, but only because a single page has been scanned. So when you look at the Alerts tab, you can only see a few medium and low alerts. But we know that the application is damn vulnerable, and there are a lot of high-severity vulnerabilities. So what we have to do is create a valid user or session so that we are able to scan more. So let's start over. Exit and rerun ZAP for a brand new start. Now go to the browser, configure the proxy as the port 8080 of the local host, and visit the DVWA application. I log into the application using admin credential and visit a few pages on the app. So go back to the ZAP window. Here is a subfolder of DVWA, the login page, and the visited pages. Did you recognize the yellow flags next to the pages and folders? Remember, ZAP runs the passive scan all the time you use it, so it's running now and reporting the findings. Look at the Alerts tab below. So before creating a new context, it's better to talk about some of the contexts of ZAP. Contexts are a way of relating a set of URLs together. So you can define any context you like, but it's expected that a context will correspond to a web application. So it's recommended that you define a new context for each web application that makes up the system you are testing, and set them in scope as you test each one. Now, right-click the DVWA subfolder from Include in Context submenu. Select Default Context to add the application into the default context. The Session Properties panel opens. By clicking the root node of the default context, you can change the name of the context with an appropriate one. Click OK to close the Session Properties panel for now. So as you see, the DVWA subfolder and the files in it are marked with a red sign. So you can open the Session Properties panel at any time using the button in the menu bar. Let's click the button to open the panel again. Here we have some details of the context. For example, click the Session Management option. You see the currently selected session management method for that context. In the Authentication option, we're supposed to select the authentication method. The authentication method of DVWA is form-based authentication. So I leave it with the default values for now and click OK to close the panel again. Now, find the login request on the left side. You see the parameters in the parentheses. Right-click on it under the Flag as Context submenu. Select Form-Based Auth Login Request option. Session Properties panel appears. And as you see, the authentication method is selected as Form-Based Authentication. And the configuration fields, such as Login Form Target URL, are filled automatically. Well done, ZAP. Here we should select the correct parameters. Username parameter for the username, and password parameter for the password. Click OK to close the panel. Now reopen the Session Properties panel. So do you see that the login request post data is prepared to be able to use it with different username and password pairs? But before closing the panel, let's enter one or more valid credentials of the application. So select the Users option under the Context node. The admin credential is already collected by ZAP. So once again, well done. Click the box to enable it. Click Add to add another credential. Give it a name, enter the username and password values, and click Add. So now 2 credentials are added and enabled. So just under the Users option, there's another option, Forced User. You can select a user here which will be used for all the requests made for this context, only if the Forced User mode is enabled. Click OK and close the panel. So looking back at the menu bar, here there's a button to enable Forced User mode. It's disabled by default, but click the button to enable the Forced User mode. Now let's go to the Session Properties panel once again and select the Authentication option. There are 2 other options at the bottom of the page. While crawling or active scanning, ZAP will try every single link and field. And during these tries, it will probably log out the application. And in these cases, the application will understand the logout and then re-log into the application to be able to keep going. So that means we have to teach the application when it's logged in or not. And for this purpose, we should find something which can only be seen in the private pages. And by that, I mean the pages you can only access if you're logged in. So close the panel. Find a page which is accessible only if you're logged in, for instance, index.php. Go to the Response tab and look at the body. Select a part of the body. This part looks good. Select the pattern, right-click from Flag as Content submenu, select Authentication Logged In Indicator. So the Session Properties panel appears again, and this time, Rejects pattern identified in Logged In response message is filled in with our selection. So close the panel. Now we're ready to attack the app. Select the DVWA subfolder, right-click on it. There are several options under the Attack menu. Of course, we should spider the app first, so in the Spider panel, select the user, context is already selected, and click the Start Scan button to start the spidering phase. And spidering is finished in seconds. So now we have some alerts in the Alerts tab, which have been collected by the passive scan module of ZAP. And we have some new pages in the left-hand side of the app tree. Here there's a subfolder named Vulnerabilities, and there are more pages inside the folder. So go to the History tab. We see a lot of consecutive authentication attempts. It seems that something went wrong. But never give up. One of the most important things in penetration testing is being patient. You'll encounter a lot of different problems in a test, and you should fix them or find other ways. So let's have a look. We may have made mistakes when assigning input values, login URL, logged in pattern, or credentials. Let's go back and look at the application tree again. Oh, wait a second. Are these requests to change a password? While crawling the application, ZAP tries ZAP word in every field. Unfortunately, in the DVWA application, there are a few pages to change the password, and these pages only ask the new password and confirmation of the new password. They should have asked the current password. But you know, this is a damn vulnerable application. So the password change attempt looks like it's unsuccessful on CAPTCHA page, because it also needs the CAPTCHA to be validated. And when we look at the request for the CSRF page, we see that ZAP sends ZAP word for both the new password and confirmation of the new password. So it seems like a valid password change request. So now let's look at the body of the response now. Here is the password changed message. It looks like ZAP has changed the password of the admin user accidentally. Well, is it true? Did the password of the admin user really change? So I go back to the browser, log out of the app, and try to log in again using the admin credential. Nope, no chance. Just as we guessed, ZAP has changed the password. So let's try to log in with the ZAP password. And to show you the password I enter, I'll use a small trick. Right-click on the password field, select Inspect Element. Change the type of field as text. Now enter ZAP into the password field and click Login. Yep, password of the admin user is ZAP. So how about a little summary? What the heck happened during the spidering phase? On the CSRF page, ZAP filled in the fields with ZAP keyword. There are two input fields on the CSRF page, new password and the confirmation of the new password. Since they are the same, it was a valid password changing request. When ZAP clicked Submit on the page, the password of the current user, admin, has changed. When ZAP logged out of the app, for example, by clicking the logout link, it tried to log in again, but because the password is no longer admin, it failed to re-log in. And it was the end of the spidering phase for authorized pages. So a huge warning comes in here. If you're testing the real application, you're always a potential threat to change or delete some important values. You have to be very careful, and beyond that, you should include the critical pages from the automatic scans. So, let's reset the database of DVWA so that the password of admin user will be admin again. Click Setup button, and then click the Create Reset Database button to recreate the database tables of the DVWA application with the default values. Now the password of the admin user is admin again. So I'll log out of the app and re-log in using admin values. So to avoid the password changes on the next phases, I'll exclude the page which changes the password. So find the CSRF page, right-click on it, and in the Exclude From submenu, select Scanner. The URL is added to the Exclude From Scanner list, so the scanner module will not visit the CSRF page and does not change the password. So now we're ready for the active scan phase. Right-click the DVWA subfolder. From the Attack submenu, select Active Scan option for this time. In the Active Scan panel, select the user which will be used during the scan. Context is already selected. Click Start Scan and let the show begin. So that scan took longer than an hour. And depending on the network speed and the size of the application, a scan may take several hours. So go to the Alerts tab. You see the vulnerabilities found. And as expected, there are several high-severity vulnerabilities such as path traversal, SQL injection, XSS. But don't worry, we'll see them in detail. Let's first analyze the path traversal alert. As we said before, automated tools generate some false positives. So we should verify the findings to see if the vulnerability really exists. The request used to find the path traversal vulnerability is a GET request. Here is a payload. Now it seems ZAP tried to reach the password file under the etc. folder. And let's look at the response by clicking the Response tab. And there you see the body of the response contains the content of the password file. And here are the users of the system which hosts the DVWA application. So if you double-click an alert in the Alerts tab, you see the details of the finding. Here, there's a long description of the vulnerability. And here is the solution. And these are the references to learn more about path traversal. And this is the attack parameter. It's called payload. This is the evidence of the finding found in the response body.